o'clock on the dot. And so I want to welcome you to the Kentucky Center for Mathematics. This week, our focus is on fractions, and we will be learning from regional consultant Cindy Aossey. And so Cindy, I look so forward to learning from you.
Thank you. I'm very excited to be here. I'm going to launch the week and focus on some of those foundations that are laid in first, second, and into third grade. Okay, get on the right string. So my name is Cindy Aossey. My contact information is there. I'd love to hear from you, and happy to be here on May the 4th. So we already had our little chat about Star Wars holiday there, but I wanted to honor that. This session and lots of other sessions are available on our KCM website. If you go to the virtual resources, you'll see the links for all our prior sessions and sessions as we look ahead. So today, we're focusing in on fraction foundations. I'm going to talk a little bit about the research and the research that's going to underlie all of our work for the entire week. Beyond that, Beyond that, I want to look at the geometry standards that support fractions work happening in first and second grade and into third grade, and how when we transition into third grade, we're really starting to get formal about our fractions instruction, and in particular, the fraction notation. So the research that's going to underlie our focus for this week, and I wanted you to know about, is this IES practice guide. This is a document put out by the government, What Works Clearinghouse, that synthesizes the research about how to teach fractions, starting from kindergarten all the way through grade 8. Because the reality is, we've not taught fractions well. We have studies after studies and decades of information that really shows that just an unfortunate number of people really don't have that grounding and understanding of fractions as numbers, understanding the size of fractions, understanding fraction operations. So we need to do something different. It has to change. And so this research underlies and tells us what that should look like, how it needs to change. And that's laid out into 5 different recommendations of changing our instruction. So the link is here. Also, if you go to my handouts, the first page of the handouts is just links, link after link, and so all these resources will be available. So there are 5 recommendations of what needs to be happening differently. And the first recommendation is going to underlie the work that we're going to do today. And it basically says students come in with a tremendous amount of informal understanding. They've had to share with siblings and cut, partition and cut things apart since they were itty bitty. And so if we can really anchor to that knowledge and anchor to that intuition, and then look at our instruction as formalizing that understanding, it's much more powerful. So I want to talk a little bit more today about how to do that. The second is, I think, probably the biggest, and I look for Dee's session tomorrow to dig into it more, is that ultimately students absolutely have to own and understand that fractions are numbers. They are quantities. They tell us how much of something we have. They describe, just like having 3 apples or 4 apples, we can have half an apple. It's just naming a quantity and has a size. So fractions are numbers. And one of the main ways to support students in that understanding is through number lines. So number lines are powerful for not only understanding fractions or numbers, but then operating with fractions. So Dee's going to take that particular recommendation and dig into that some more tomorrow. Then we start using those numbers, and we add and we subtract and we multiply and divide, and we do all these operations, and students need to understand why they make sense, right? It can't just be this arbitrary dance and wait, do I have any common denominators here or not? Do I cross multiply or and we know that kids just get bogged down with all these rules about what to do when they see a fraction, and it doesn't work, right? They get through that test and then they go to the next test and they forgot everything that they knew before, much less what they knew the year before, and we're just reteaching it over and over. So how do we fix that? We start from understanding. And so our sessions Wednesday, Thursday, Friday are going to take different components of that and really dig into how do we use visuals and context to make sense of fraction operations. The 4th recommendation deals with building that proportional reasoning that is the hallmark of middle school. So remember that document with K8? And so in 8th grade, or sorry, in middle school, in 6th, 7th, and 8th, we start seeing strands that are the RP standards, the ratio and proportional reasoning standards. And we really need to move kids. Some of you have been with us in other sessions. We move from the counting strategies to the additive to the multiplicative reasoning. Well, in middle school, we're moving to that proportional reasoning. So kids really need to understand that. We have a whole week that we were developing some of that proportional reasoning. But one of the things I find fascinating about this particular recommendation is they're very specific in this one sentence. They make the point of saying we need to understand it before exposing them to cross multiplication as a procedure. Where else in our standards have we seen examples that, too early exposure to an algorithm or a procedure does harm, right? First, second grade teachers, you're like, yep, we're not supposed to do those, we don't want to stack and add because they lose the place value understanding. We don't want to jump to long division before they understand what division means. Well, in middle school, we don't want to jump to cross multiplication before they're understanding that they're working with fractions as numbers and understandings of equivalence. So I love that recommendation, although it is living mostly in the middle school. And then the 5th standard, or 5th recommendation I love, is what we're doing here today. It's saying we need to grow teacher knowledge. We need to implement this research, but to do that, we need to support teachers in the knowledge. So KCM is always a joy to work for, and we get to work in person, or have traditionally worked more in person. Here's an example of one of my fractions cohorts from this year. But we're going to continue supporting you in any way we can and build that knowledge, because we know how impactful, how critical it is. Going back to that recommendation 1, and what I want you to know about this document is it gives you that quick summary, but then it gives you, I don't even know, 5, 6, 8 pages, something like that, on each of those recommendations, breaking it apart with what that actually looks like in different grade levels, what are some of the key struggles students have, and how do you address that? So I encourage you to check out the document itself. And it's tying to that early work, and the standards, what I love, have been written with knowledge of this research. So our standards are aligned to these good recommendations that are saying, start building on students' intuitive understanding of sharing by having them in 1st grade sharing out, partitioning circles and rectangles into 2 or 4 equal shares, and start using those words. Key idea there, using the words, halves, fourths, quarters. Talking about having half of a shape, or fourth of a shape, or quarter of a shape, or of this pie, or of this cake. Talk about what it takes to get back to the whole. It's going to be 2 halves to make 1 whole, or 4 fourths to make that whole. And understand, if I'm sharing with 4, I'm going to get a smaller piece than if I'm sharing with 2. Kids have huge understandings of that, so that's the standard. And we can tap into, they've had to share their Play-Doh, for example. And I'll give you a link here to this lovely blog from this amazing 1st grade teacher who's talking about doing the standard. And even though the standard itself talks about partitioning like a rectangle or circle, the understanding is what's critical there. And so she's like, oh, my kids know all about sharing their Play-Doh. So she talks through about how she explored the standard by starting with having this whole ball of Play-Doh. And says, I'm playing with the Play-Doh, and my good friend Kelly comes up, and I want to share some with her. And I pinch off and I give her this little piece. And the whole class said, wait, that's not fair. Kelly didn't get enough. And so they talked about, right, why didn't she get enough? What do you mean? And they named that as unequal. And the class said, you should be fair. You should give her the same amount. So then they split it up and they made it the same amount. And now we can name that halves. And what if we each had another friend come up? So now there's 4 of us and we share those out. And now we have fourths. And so she used this opportunity, and she did it also with circles and the rectangles, and we need to do all that. But by anchoring it to what they knew and their play and their sense of fair, the kids had so much understanding of what was going on. They can see how critical is that pieces be, if they're not of equal parts, we just have parts. But if they're equal, then we can start naming those parts using that fraction language of halves or fourths, and how those fourths got smaller. But if I put those 4 fourths together, I'd be back to 1 whole. Exactly. No notation here. We're not using the symbols, not numeral. It's words. It's words. Moving into 2nd grade, we build on it. It's a very similar standard. You see this a lot of the same language in the standard. The biggest difference is we're going to extend to thirds. So everything we did with halves and fourths, we now do with thirds as well. But they also push it a little bit further and say they really need to start being comfortable that even if our parts look different, if they're the same size, it's still a third or a fourth or a half. So I might take it with this, if I were doing 2nd grade, I might have a conversation about smashing one of those fourths and say, you know, Kelly rolled hers into a snake and Amy made hers a big flat pancake and mine's a ball. Are they still fourths? Are they the same size? What does that mean? So in 2nd grade, we want to really get into, are they the same size, even if they don't look the same? So, but notice in both of these standards, kids do the partitioning. Kids have experienced partitioning. We really need to keep that part of the standard in mind. They need to be starting with blank shapes and wrestling with the partitioning. So one of our entries, KMP Task Group 7701.1, which may not be easy to remember, but there is a link that'll take you right to the page. In fact, I'll kind of click on that so you can see it. It'll take you right to the page. It'll have the lesson plan, the student instruction pages, the printables. That's also in the, in the printable, in the handouts. It'll take you to all the resources to do this. You don't really need all this background. What you need is for kids to have a conversation. And so, yeah, I like my dice. I make my dice, and I have little people on the dice to really emphasize this is about sharing. And we have our pieces of paper, and they're all going to start off the same size. And this works really well in a small group discussion. And I have the students, you know, we roll our dice, we need to make thirds. And we talk about it more as we need to share this cake with 3 equal people. What could that look like? And we want kids to play around with that. And I might give them some tools, right? So I might give them something like popsicle sticks or wiki sticks, and let them kind of map out what they think it would look like. They might fold, they might draw. But one of the things that's really intentional about this is I want them to find ways that are fair, that are thirds. But I want them to find ways that aren't. And that is so, so, so important. They need to have conversations about why this one isn't fair, and in particular, isn't thirds. They have to wrestle with that. But it also honors that we think mistakes are an opportunity to learn. So I was working in a small group with this activity, and I had a student who really struggled to make thirds. Making halves is easy, making fourths is easy. But she had a really hard time figuring out where to plan the lines to do thirds. And you can sort of see this crushed moment when she was like, realized that what she had done wasn't thirds, but that was before she had a sense of it. It was then I was like, no, that lives on a board. She was ready to crumple it up and throw it away because she wanted to hide it. And I was like, no, let us look at it. And where do you want to put it on the board? Thank you for letting us see that example. We needed to see that example. So it's not just something to hide, to throw away, a mistake. It's something that lives on our board as an example for what isn't thirds, so we can know what thirds are. So we want kids to explore that. And they also want to see more than one way to do it. So somebody goes vertical and they see those size pieces or those shape pieces, and some people go horizontal and they play with all sorts of different ways. So they give you a nice example in the standards that we want kids to have at least these different ways of seeing how halves could be formed, how thirds could be formed, and how fourths could be formed. All in second grade, and all using whole language to describe it. So putting that together, big ideas. Remember, we're living in the geometry strand. Kids need to be attending to the size of the parts. It's about how big they are, how much area they are. We know, tons of research to back this up. Halves are the easiest, followed by fourths. That's why those live in first grade. Thirds are much harder. So in a way that you might work around that with kids, especially as they initially struggle, is have them really do that testing if something's thirds and seeing, like, making some of that decision making. But thirds are definitely much more difficult to plan out. students should be working and seeing different ways. So we don't have a rule that anytime I do fourths, I partition it this way, that way. Nope, we want to see the range. We want to see the variety. And nothing in the standards indicates they should be working with symbols. So moving into third grade. Now this is where rubber's going to meet the road. Interestingly, we live in both the geometry standards and we're going to see in a moment, now we have fraction standards. But I wanted to hit on that geometry standard because we see the progression. Same, kids are partitioning shapes. Kids are partitioning the shapes. They're going to look at the area of those pieces, but the clarifications tell us we're now moving into having sixths and eighths. So kids should be able to form and make halves, thirds, fourths, sixths, and eighths. And for the first time, we're going to expect that symbolic notation. So I think it also opens up that we want more than just simple circles and rectangles. I would encourage that even in first, second grade. One of those things where instruction is appropriate, but maybe not assessment. But here in assessment, I would expect them to work with different kinds of shapes. Also, I think in terms of materials, building with something like pattern blocks, seeing if I build this shape with 4 triangles, then each of those triangles is a fourth. If I build the crown with 3 of the rhombi, if I build with 3 of the rhombi, then each of those rhombi is a third. So we want kids to have a range of shapes, start working with those materials, and starting to use that symbolic way of indicating the size piece. But fractions live in the real world, right? You know, sometimes our academic standards get really focused on kids working sort of abstractly, but we definitely want kids to be seeing those fractions and how they cut apart a sandwich, how they cut apart an apple, seeing those measuring cups. How many of those fourths would it take to fill up to 1 cup? How many of those thirds would it take to fill up to 1 cup? Get the rice, get the water, pour it and fill it and test it. Moving into our NF standards. First time we actually have a standard that's NF, and that's standing for those NF fractions, but they're numbers, right? They're a type of number. So we define what a unit fraction is, written as 1 over a number. And I always have a hard time reading these, so I'm going to say, for example, 1/4. So understand 1/4 as the quantity, I love that keyword quantity there, formed by one of the parts when a whole is partitioned into 4 equal parts. It's exactly what that geometry standard said. We're going to be partitioning quantities. So we're partitioning shapes, but we also can generalize that a little bit. But here's where it really hits that punch. What do we mean when it's not a unit fraction, right? What if I want to think about 3/4? How do I understand 3/4? Well, I gotta tell you, I always heard it as 3 out of 4 parts. That's how 3/4 was read to me and how I worked with it for a really long time. But they're saying that's not exactly how we want to talk about it and how we wanted to say it. What we want to be attending to and reading that fraction 3/4 is that it's formed by having 3 parts of size 1/4. So if I know what 1/4 is, then 3 of those is my 3/4. So let's kind of visualize that and think about how we might use that with materials. We start off by defining the unit fraction, right? So if this circle is partitioned into 5 equal pieces, I know the size of that blue piece, one of those pieces is a 1/5. I've named that piece. That started, you know, that just generalized some of that 4th and 5th work. And I know 5ths aren't necessarily a 3rd grade unit, but I wouldn't avoid it necessarily. I just might not assess it because I think all the concepts apply and we want kids to know that. So if I know that's a 5th, then that's a 5th, you know, if I lay it on the table. Let's count with our kids. We see how important counting is all the way through primary. We don't want to stop because it continues being powerful. So class, let's count it. We're putting them out. That's 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5. It's 8/5. Anchor it back to the words, right? I have 8 of the 1/5 units. And then see how the symbols say the same thing. The 5 tells me I'm dealing with 5ths. The 8 tells me how many I have. Notice also we're going beyond 1. From very, very early in 3rd grade, we want kids to have that exposure of pushing beyond 1. And this is one of the key places where that language, if I'm trying to understand 8/5, is 8 out of 5 equal parts? Not quite sure what that means. Having 8 of the 5th pieces, I know what that means. And I can have conversations about how 5 of them would make one whole. And so what I really have here is a full circle and 3 more circles. And we could have those conversations as well. And that's exactly what you do in 4th grade. But it comes from that understanding of seeing those fractions as built out of the unit fractions. So it really builds on our prior understanding. 6 teddy bears and 2 teddy bears, preschool, kindergarten. We're getting out stuff, we're telling stories. Lisa has 6 bears, Cindy has 2 bears. We put them together, and how many bears do we have? And we can count them, and we can figure out it's 8. And we can figure out that that's happening when it's teddy bear counters, when it's fingers, when it's dots on a page, anything we're using in our classroom and in our home. And eventually we realize it's not about it being bears or fingers or dots, but it's about that quantity 6 and 2 more is going to be 8. Then we complicate the world a little bit because we throw in those 10s, and now we have to really distinguish, and we have to know that these things about combining that 6 and that 2, well, it works when I'm adding the same kind of things. So if I'm adding 6 10s and 2 10s, I've got 8 10s. Pushing into 2nd and 3rd grade, we're starting to introduce those additional place value units. We've got hundreds, 600s and 200s, 800s. So now, getting into 3rd and 4th grade, I want them to just own thirds, 5 6/3 and 2/3, 8/3. We're also going to be starting to expand our place value system into the 10ths and into the hundredths. And middle school teachers, it's just it's like terms, it's combining like terms. And I love this, this idea that it's the units. Kids need to be thinking about when it's the same kind of unit, I can add them up. And I'll just mention, some of you may use Engage New York or Eureka. They actually call their curriculum, that K-5 curriculum, a story of units. And I know I didn't think much of that for a while because I kind of thought they just meant like instructional units. But then I realized their middle school curriculum was called a story of ratios. I was like, oh, they mean these kind of units, this mathematical idea of working with a unit. That's that one word that they pulled out to describe K-5 mathematics instruction. It's to understand units. So we want fractions to see this natural extension and growth of that. And so we have some activities, again, to really encourage kids to be thinking about the size of the pieces and then what it might mean to have multiple copies of that. Link to take you actually to the K&P page. If you go there, you have a printout, again, for work mat. And then you have sets of cards. And for example, in card set A, it gives you a rule. And you're going to sort cards that show halves and cards that do not show halves. So these are the cards that you would have. And they're worth it. And there's a whole bunch of cards there. But I was going to say, like, it's hard to get the cards to the kids right now. So right now, you also have access to a Jamboard. And I'm going to go ahead and take you to the Jamboard. And it has this card sort recreated so that you can move the cards virtually. And it looks like it's taken my, okay. Now I'll tell you a little bit. You'll have a link to this. And then, so you get a copy. And then what I do when I'm using it is I always duplicate the page before I start moving stuff around. Then I can work on that duplicate. And that way I don't need to put everything back. I can just delete that page when I'm done. So kind of similar activity to before, but now I'm going to go ahead and instead of having the kids create the example and counterexample, I've created some because I want to make sure they see a full range. And it starts off pretty straightforward with halves and not halves. And so we have kids sort through and see those examples. It gets a little more progressive. We have fourths, push them into thirds. Remember, fourths are easier than thirds. Get into eighths, because we want third graders for sure wrestling with eighths, seeing things like counter examples, seeing though that there's lots of different ways to correctly partition into eighths. But we also want to start building in that language with the shading and start seeing having 1/2 of a shape. Of course, that's one of the counterexample cards. That's not 1/2. But again, seeing here, I do have 1/2, but here I don't have 1/2. So this idea that shading is telling us what part of the region we have. And then we kind of ask them to wrestle with things that are partitioned in a lot more ways. So for example, this one. How do we have kids figure out if that's 1/2 or not 1/2? And this one really pushes them to start mentally maybe moving the shaded region, because it's about the size, not about the location. So when they can start saying, well, if that shaded region were here, and this shaded region were here, and this shaded region were here, now I can see the 1/2. But they can also see it as 8/16. So experiences like this, especially going into 4th grade, I'm going to really pull out the equivalencies, because that is not easy to see. I'm not sure I'm going to expect every 3rd grader to see it. But I can sort of pick up here and have those conversations, and for 4th graders, for sure, start formalizing that as seeing equivalent fractions. 3rd graders should do some equivalent fractions, but we need to kind of balance. Like this one, that one, you know, 3rd grade, yep, we should see the 2/4 is the same as 1/2. That one's pretty accessible. Yeah, that one's gonna be a little challenging. So we can build on that and have some discussion. And same thing here. So we have a range of cards, different things that they can play with, all ready to go, and you have the Jamboard. Now I want to tell a story, because I was doing this sort with a 5th grader. And he's a good student in a lot of ways, but he was struggling in math in particular. And I was actually testing the cards with him, and he sorted it this way. So here's my question for you. I have the chat open, or you can go ahead and unmute and talk about it, what you're seeing. But I've observed that this is what he's done. So the question is, what is he understanding about halves? What is he not understanding about halves? And as a teacher, what are you going to do in that moment? What are you going to say or ask or do to support the student based on what you're seeing in this work?
The student understands that halves are 2 pieces, but he doesn't understand that they're equal.
Yep. Yes, it's exactly what I saw in there in that moment. For him, it was just about the number of parts. It's 2 parts. And so what do we do about it, guys? You're in that moment. What are you going to ask him, or how are you going to approach that? Exactly. Yeah.
You go back to that question that kindergarten's 1st grade, is that fair?
Exactly.
And depending on the age of your student, you know, and I do this with some of the kids I work with, you know, you're sharing pizza with your best friend, and I'm in the smallest school, I know who their best friend is, you know, or you're sharing brownies. Is that fair?
Exactly what I did. Card 2 said, is it fair? He's like, no. It's like, well, but it's not halves. And he just looked at me and says, well, if that's your rule, and then sorted it out. So we had a conversation, because we have to understand in mathematics, some things are convention. It is our rule. It is our rule that the pieces be equal size. He just never caught on to that rule. And I guarantee you his teachers had talked about equal parts. I guarantee it. I know who his teachers were. But I don't know that he had ever had to wrestle with why this wasn't halves. I think he had only seen examples that were cut correctly. And so we need to make sure kids have that exploration. And I love that you guys tuned into that so quickly. So why that counter example? It's so powerful. So a quick image there to show you some of the different card sets. This is from Vanderwall. This is also in your handouts, and there's also a Jamboard for it. Because I like moving beyond the rectangles. I like, you know, cutting fourths into triangles. I've had kids argue, well, the widths are the same, and they don't necessarily use that word, right? But I've had one even say, we're just looking at the distance from here to here, the other doesn't matter. Because for whatever reason, their experiences in their classroom told them that that didn't matter. So we had to have a conversation about, well, yeah, it does, because we're paying attention to the size of the piece. Would you get us enough cake if we cut up our cake that way? And then something like G, ooh, G is interesting, right? Because is that fair? Well, our pieces look different, but they're the same size. And so we can have really powerful conversations pushing into that. You have this as a PDF, so you can put it in a paper packet, but you also have a link to a Jamboard, so you could assign it digitally and have kids do the sort. because we don't know what teaching is going to look like next year, do we? And then I love questions like this, and I'm just giving you a bank of questions like this that really force it to be about size. Because boy, this throws all those rules about number of pieces out the window, and I just have to think about size. So we can start with a pretty open question of what fractions do people see? There is a link to a Jamboard here. And so I'm going to run from the Jamboard here because I have a couple different questions. So I might record it this way. In fact, let's go ahead and do it. Because I already have space here that we can record 4 different fractions that people are seeing. So if we have volunteer to unmute and sort of tell me what region you're attending to and what's fraction name for it, what's its size.
I see 1/4.
Okay, and tell me how you're seeing the 1/4. What region are you paying attention to?
The left top square.
So that region right here?
Yes.
So with kids, I might do like a thumbs up, especially if I'm in person. Give me a thumbs up if you saw 1/4. And maybe pull out, do you see another, is there another way to see 4th in that image so we can play with the 4ths? Let's maybe look for a different fraction because we can think about, after we've had sort of some of that 4th discussion, oh, are we seeing other fractions in this shape? Volunteer for that?
I see. Go ahead. Okay. I see 1/8.
Tell me about 1/8.
If you look at the square below the 1/4 that you shaded on the first, you have the square divided into 2 triangles. So each of those triangles is an 8.
Yep. So each of those is an 8. So I'm going to pick one of those. But I like that language because that one's an 8th. But I think it's also worth pointing out that that one was also like an 8th, right? So you can think about how you might want to notate that, but that one's also an 8th. And now we're seeing examples of that 1/8 and 1/8, those 2 8ths together is the same size as a 4th. Some kids are going to start seeing that language. Some are going to be seeing that idea there, that it was a half of a 4th. I'm pushing that already into 5th grade, but even without the sort of 5th grade terminology and those 4th grade operations, I think kids can even by 3rd grade be starting to attend to, if I know that size of that piece. You could also argue it with how many of those pieces will it take to get back to the whole? Can I see that there are 8 of these triangles that would cover the whole? And so it's another way to argue why is it an 8th? So all sorts of math coming out of that. Let's do one more. I am fun with that. I like those different ways to see fractions in here.
I see 1/12.
Tell me where you're seeing the 1/12.
It is on the top right, one of those sections of that top right square.
Cool. And again, tell me your justification. How do you see it? Why do you know that's 1/12?
Because it would take 12 of them to go to make the whole big square.
And so kids can be doing stuff like that. I'm mentally thinking about, take 3 of them to cover that space, 3 of them to cover that space, that's 6 of them, and then it would take another 6 to cover it. That multiplicative reasoning that turns into the fractional reasoning and that proportional reasoning. So pretty cool stuff there. I broke my own rule. I forgot to duplicate that page, so I'm gonna have to delete all that in a minute. Another similar shape, but a little more complicated, so this is one I use in middle school, is called the unitizer. This is from Le Mans. So same kind of questions, what fractions do you see? Also in your packet, you're gonna see some activity pages that have some pre-shaded pieces and say name the fractional part, or some fractions and say go shade that amount. And then another one, I've been seeing these amazing math walks, ideas of putting that out there for your neighborhood to do. But I also loved this image, and look for ways to see an 8th in this image. So those resources are on there for you. Also the links for where some of these things came from. This is actually originally, this image was from Marion Small, so I want to give credit for that. There's a lot of other images on fractionstalk.com that you could play around with that kind of question. The unitizer that I showed you, these handouts are in your packet, they're coming from Susan Le Mans. And the sidewalk chalk has this amazing bank of questions called Math Walks. So if you live in a busy area and want to get out there drawing, I think I need to do that because I'm close to the Capitol here, and I think we have some government officials who need to do some math, that we can play around with all sorts of amazing puzzles and ideas for visual mathematics. And again, Jamboard that you could go on there in color. So if you're working with kids and you want them to share their ideas, ask some people to tell me the ways they see 1/8. And I just wanted to give you a sense of all the different creative ways, but also how that opens up the door, how seeing the 1/8 could also see it more like 2/16. Here we see a 16th and 2/32. All sorts of different things going on there. And I would encourage people to find other fractions that they can see in there and figuring out what those values are. So lovely, awesome, creative images to play with. In your packet, so you have links to lots of those resources. They're also embedded in the PowerPoint, so you can get to them that way. You have a couple of the K&P activities ready to go there, or you can go to the K&P site. Coming up, we got all sorts of fractions work happening. We've got D on the number lines, and we're going to dig into those operations. So we hope you'll come back and join us. As always, everything will be there on the website for you to find either now or later. And I'm Cindy Aossey. Feel free to reach out. I'd love to hear from you.
So every afternoon, the KCM has a beautiful session just like that. Cindy, how wonderful for me to be reminded of all the cool things, and your integration of technology is just fantastic. We love that you put some great shout outs in the chat, but we also should like to hear you with our ears. So unmute. What part was one of your favorite things about this session that Cindy just did for us?
Cindy, go ahead.
Go ahead, Jennifer.
I liked on your sorts. Not only did you know, like your halves one, you had obviously what was half and what was not half, but was still technically a fraction, but it was like a third or a fourth, you know, to really see that at that moment, that fraction doesn't apply to what you want or what you're asking.
Yep, it can have a fraction name, but not be the one we're asking about. I like that point, and that was definitely something I wanted in that sort. Thank you for highlighting that.
I love the sidewalk chalks. I want to go paint my driveway now and tell my neighbors to all bring their kids over and write down what fractions they see. At least I'll be teaching somebody.
I thank you for sharing the Jamboards. I think that's a great, looks like a great resource. I have not experienced it before. And so I appreciate that. I will share it with my Rockingham friends.
Hi. Cindy, I love the new resources, the reference to the Math Talks, something that was new from our whole series. I was thinking that, or I missed it in one of the times, but I loved that one. And then going back to some of the work by Marion Small, a really important math thinker for us. So indeed, Jamboard is part of the Google Suite. It's an add-on if you happen to have the Google Suite, one of those resources that, or one of those apps that we really do love. Cindy's extra good at it. Every afternoon we bring you a 2 o'clock Zoom session. This week happens to be focused on fractions. So we are so glad that you guys join us. Be here tomorrow, same place. You can also retweet us or share the watch party as a watch party, or share it our Facebook Live site. So we thank you so much. See you.